Please put your hands together for Patrik Schumacher.
Good evening. Very happy to be here. Thanks to Grohe. I'll be talking about a built environment that is adaptive, responsive, and yes, creative through computational intelligence. So this is a new language of architecture called parametricism. Over 10 years ago, it's really a global new style which encompasses everything from urban design through architecture, interior, product, even fashion. And I just flicked through that, and we started with cultural institutions, but now we're really addressing every scale and program domain like we should as we take over modernism and the 20th century way of designing and building through new technologies, because we are in a new era. An epochal style is required for a new epoch, a new era. Of course, there's a whole history of computational intelligence. We are building on this openness of a research community is, of course, very important to make these possible. So we use those to generate an installation at the Biennale using robotic cutting, scoring, and folding and of these segments and elements to generate a super light aluminum shell, which is only 1.5 millimeter gauge, and a beautiful piece bolted together. And then again, the bolts themselves become, and the seams become, form of ornament where you can see how the forces flow, and the particular form, the detail is always coherent with the surface. We also work with using primary and secondary stress lines as articulators. This is efficient, then applied to a shell. And you can see the beauty coming through and the efficiency. We created a kind of version of a candela shell, made it asymmetric, applied the grid, this kind of intricate grid shell rather than implying a basic platonic grid. We layered the different densities or stress intensities with layers of 1, 2, 3 pipes, and we generated something highly articulate. And you can trust this, you feel it, you know where the entrances are, you know where the support points are, and it becomes highly sophisticated. The same with tensile structures. And again, we're working through little pavilions, temporary buildings, into large structures. And this is a combination of shell and tensile. We're winning, for instance, Olympic Stadium, Tokyo 2020. And we're doing buildings in various places around the world. Super high-performance concrete umbrellas, a facade as fabric, clear fabric. These are the kind of ideas we're working with. 3D printing. The intricacy of 3D printing allows for the sophistication of design. This maybe the lightest shell you've ever come across. Super light, super strong. And then applying that to pavilions. The next layer of optimization is fabrication. Because this is not 3D printed, but made out of sheet materials and straight parts. And also generates some quite elegant and very efficient. So this pavilion looks like a sculpture, but it is super efficient, produced out of parts which come out of our cutting schedule. Here we're doing benches, hot wire cutting, 20 times faster and more efficient than milling polystyrene molds. And again, there's a characterfulness and uniqueness of these particular forms and this formal universe. And then we also like the fact that you can see the manufacturing process imprints its characterfulness, not to know that how it was done, but it gives it uniqueness and character. And so that is the world we're working in. We're working with students from the Bartlett. In our show, we show young startup companies. In our gallery, we're working with multiple startup companies like Nagami here, creating these intricately printed, 3D printed chairs. I'm also a fashion designer for my own sake. So parametricism moves and tectonism moves through all these techniques, also structural design. We started to give our towers expressions through skeletons. So there's a kind of transformation from bottom, middle to top, and you can then fold into this and correlate various types of residences which become possible, 3, then 2, then 1 at the top, and you make unique and characterful and differentiated structures rather than kind of seriality of mass reproduction. And you generate an enormous amount of freedom on the inside. So this is Macau, that open, deep space of flying, basically, where you navigate a tower like this, like a street, where the different events are unfolding when you move up and down the panoramic elevator. But then there should also be differentiated things and spaces suspended in that void. You can always remain in contact with the outside as well. So So these are the kind of spaces and individually crafted, conditioned, and varied experiences which are possible in such a building. So also just briefly show that we're scaling up with these techniques, and we won the competition in executing now Beijing Airport, a fantastically large column-free space in the middle with a lot of glass and using structure as orientation, so you can kind of, these gaps between these petals, you moving out to the gate, and you get something quite unique, quite different, quite other, where form and space, void and light, orienting media in this big space. Environmental features, buildings should look different from different sites and different sun exposure conditions, like in Baghdad here, rather than making glass towers and then pump energy, or something like this kind of field of air flow and shading in a research campus in Saudi Arabia. So we're getting something which is the imprinting. You can see here the air is flowing in, the sun is taken out, and the same forces play on solids and their courtyards and the lightweight canopy. So they are affiliated through being subjected to the same parameters and forces. And you get a highly porous, continuous field conditions with atria, with courtyards, with a lot of outdoor space and light spaces, and the continuous porosity, continuous connectivity, but also many places and spaces of character and distinction in this continuous matrix, which isn't a jumble, it isn't a random agglomeration, but it is a orchestrated field condition with a lot of laws and logics driving that. And that's, I think, what parametrism and parametric rigor brings. It brings traceability and inference potential. If something is evolved according to laws, it also then becomes retraceable through laws. And the last cycle of experiments we're doing is making this environment not only statically responsive to conditions, but dynamically responsive, and spaces which migrate and fuse and connect, where ceilings cajole and invite and respond and amplify gatherings, where we have reconfiguration potential between the various agents and actors in a field. And we're using game engines and autonomous agent design with their various brain structures, decision trees, or in fact utility functions roaming around, and the same we're starting to employ and give to the architectural agents. So they become players and actors imbued with tactics and utility functions in a world of optimization. You can see here that we want to imagine spaces always now with the diagrams, social diagrams, the way architecture and space and design communicates, frames, invites, and structures social situations, orders social process. Here you can see complex scenarios. We can see where multiple agents, multiple spaces, and a porous texture, again, with intimacy and simultaneity, connect up, play with each other, roam around, find each other, and the way this architecture plays an active role to orchestrate, so we don't run down empty corridors, we can maximize our participation in urban dense environments. So that's the theme, and that's why we need AI-empowered architectures to make this happen. Thank you.